Now that we understand the basics of VTL, we can build some templates to be added to DNA Center. Once complete, we can render them to check for correctness. Before we explore the code, note that the templates directory contains 3 different templates. Template bad contains some errors that can't be processed, so our script should gracefully handle that case. The other templates are valid and should be rendered without issue. We'll scrub those files later, but first, let's explore the build-templates.py script. As usual, we'll use OS to interact with the file system and JSON to load templates from a file. We'll also use our SDK to simplify interaction with DNA Center. Let's jump into the main function. We'll continue to use the DNA Reservable Sandbox environment via the DNAC variable. Then, we need to create a project which contains templates. We can supply a name and optional description in the HTTP body, then create a new project using the post request shown. Like many creation-related tasks, this API call is asynchronous, so we'll wait for DNA Center to finish making the project. Here's what the response body looks like after the task completes, and we'll extract the data value containing the project ID. Next, we'll load in all available templates in the templates directory and process each one individually. The first step is loading in the template data from each file. Then, we'll attempt to create each template using both the template body we just loaded and the existing project ID. Let's quickly explore the templatesimple.json file to better understand the structure. The first key in the dictionary is body, which is the HTTP body of the post request used in creating a new template. The name is simpletemp, and this is a standalone template, not part of a large composition. The template applies specifically to the Catalyst 9300 switches that run iOS XE and are present in the DevNet sandbox. Finally, we get to see some VTL in the template content field. The template updates the FTP source interface and SSH version using simple variable substitution. Next, we need to define our parameter metadata. FTP src is a string and is required. This would be something like loopback 0. SSH ver is an integer and is also required. By specifying the data type, DNA Center can ensure that valid values are being supplied. In addition to the body key, I've defined the params key, which contains the actual input values. Notice that FTP src carries a string and SSH ver carries an integer. We'll supply these when previewing the template. The creation API call is asynchronous, so we'll wait for completion, then extract the template ID. The structure of this response is similar to that of the project creation process, and here's a callout to reveal that structure. Next, let's preview the template. Sometimes this is called rendering. In the HTTP body, we must specify 2 keys. The params key must, at a minimum, assign values to every required variable, which we included in our template file for cleanliness. The template ID key is self-explanatory and identifies the template to render by ID. We'll use an HTTP put request, passing in our prev body variable and storing the response. This operation is synchronous, so we don't need any extra logic to wait for completion. Sometimes it is useful to see the template ID for future troubleshooting, so let's print it to the console in a status message. If any validation errors occurred, let's iterate over the list of errors, printing out the type and message from each one. Here's an example of what the validation errors might look like in JSON format for reference. If the validation errors list is empty, that means success, so print out the CLI preview text. This is what will be pushed to the devices, and we'll print it to the console to manually review it. Here's what it looks like in JSON format, but I think you get the idea. For now, we won't version and deploy this template, as that's coming later. I've commented out that function call for the time being. Before running the script, let's quickly explore the 2 other templates, template complex and template bad. The complex template introduces if statements and for loops, which you can test offline using the VTL CLI Docker project we discussed previously. This time, we have a list of strings with some default values defined. The JSON structure that DNA Center requires is somewhat complicated, and defining default values seems required. Notice that the selection type of multi-select and parameterArray being set to true identify this as a list of strings. The second parameter is NTP logging, a simple string. DNA Center does not appear to support Booleans at this time. At the bottom, we supply the values we want to use for rendering, which includes a list of NTP servers and whether logging should be enabled or not. The bad template is simpler as the template content is identical to the simple template. We are just trying to update the FTP source and SSH version. However, rather than specifying an integer for the SSH version, I've included a bogus string. DNA Center should catch this and fail validation for this template. I'll quickly clear the screen before running the script. Now, let's preview our templates using the command shown. The script processed 3 templates. Alphabetically, it discovered the bad template first, and validation failed due to invalid data per the callout we saw while exploring the script. Next, it successfully rendered the complex template, enabling NTP logging and configuring 2 NTP servers from a list of strings. Finally, it renders the simple template, which updates the FTP source interface and SSH version. These snippets look good to me. You're probably wondering how we can deploy these snippets to network devices. Let's explore that in the next clip.